what are the advantages and disadvantages using computer? The advantages are speed, reliability, consistency, storage, and communication. So we will discuss each and everything in between, because calculation speed is very high. Whatever we want to perform, it is very high. Okay. Although the brain of computer is much slower than human being, but speed of computation, mechanical computation, where the formulas are fixed, here the speed is very fast. Reliable means you can easily trust on the result governed by the or given by the computer. Then come to consistency, means today the result is same and tomorrow the result is also same. Then storage, tremendous storage is there. Communication, ability to communicate, like I am teaching from my place to your remote places also. So this all
Good
thing
morning,
is
sir.
very good morning, very good morning. Now come to disadvantages. If we are using computer, if we are using computer throughout the day, then health risks are possible, okay, due to its radiation and heat waves. Then violation of privacy, like I'm recording your classes, okay, I'm recording your classes, and each and everything is recorded here. Sometimes what happen, because this is class, recording is a must, but normally most of the time it is not a must condition. Then this violates the privacy of student. Fine. Of privacy of human beings also. Public safety is another risk related with computer. Impact on labor force, because each and everything is done with the help of computer. So labor force is not able to get job. It is means ऐसा लगता है, but we are creating labor force. Okay, computing is one job, and suppose if you want to construct a house, machine only is not sufficient. So many things are associated with this. So everything we need to use. Okay. So labor force get not affected, but it is one of the disadvantage although. Then impact on environment, because we are using computer, everybody is using computer, then it will left the carbon footprint. Okay, so this carbon footprinting is disadvantageous for environment. Bhutan is the country which is carbon negative country. Okay, they are not emitting carbon dioxide, and whenever we are going to, like, whatever video and audio I am sending you, it uses wire uses power is coming from some electricity office. That electricity office burns coal, and due to this coal burning, it will automatically give impact on the environment. That's why it is written that um, impact on environment. Fine. Now come to history of computer. So history of computer, inside that, first computer was abacus in 4th century. So some of you might have idea about abacus because they have joined their abacus classes also. So abacus is a simple counting aid, may have been invented in Babylonia, now in Iraq or Babylon, in the 4th century before Christ. Okay, means year 0 से भी 400 साल पहले की बात है ये. This device allows users to make computations using a system of sliding bits. ये beats are there arranged on a rack. Okay, and considered the first computer because it gives computation by using these beats and sliding these beats. It will automatically compute the answer. Then in 1642, not 19, in 1642, the French mathematician philosopher Blaise Pascal invented a calculating device that would come to be called the adding machine. Okay. So this was the first and earliest mechanical device used for calculating, and it was known as Pascaline, originally called numerical wheel calculator. So how the computation is done, you can see here. So carefully watch this video, so you may be able to get how Pascaline is used. Okay.
So the video is not visible.
Video is not visible now.
Yes, sir.
Now it is visible.
Yes, sir.
No, sir.
Sir, visible.
Okay. So recording will be there. Don't worry.
Sir, अभी भी नहीं दिख रही.
It is lagging in some places because of video. Okay. So this machine was um, okay. It was known as Pascaline, and Pascal's invention utilized a train of 8 movable dials. Here only three movable dials are shown, and this is the original machine. Actually, in animation it shows only three to explain you. Otherwise, there are 8 dials. Fine, or cogs to add sums of up to 8 figures long. As one dial turned 10 notches or a complete revolution, it mechanically turned the next dial. Fine. Pascal's mechanical adding machine automated the process of calculation. Although slow by modern standard, this machine did provided a fair degree of accuracy and speed. Only performed addition, not multiplication or division. So this was a disadvantage, but this is very excellent machine, and it was invented by Blaise Pascal. And after his name, one language was known as Pascal. Okay. Now come to birthright लेबनीज थ्योरम आप लोगों ने सुना होगा है ना लेबनीज तो his machine was the stepped reckoner or stepped wheel supposed to be able to add, subtract, multiply, divide and calculate square roots, and this device never worked properly. Okay, so let us see what is the how it works. So this is a machine mechanical calculator. Here to suppose you want to multiply 7 cross 5. Okay. So initially we set gear to 7 and move it 5 times. Second iteration, then third iteration, fourth iteration, fifth iteration. Okay, now the answer is 35. You can see here the answer is 35. Clear? So this was the device constructed by Leibniz. Okay. Now come
सर
to Charles Babbage.
एक्सक्यूज
Yes,
सर वो पिछले वाला
yes,
ओनली 2 डिजिट नंबर्स के लिए था ना,
हाँ,
मल्टीप्लिकेशन.
yes. Okay. So Charles Babbage, he is considered as father of computer. Born in 1791, Charles Babbage was an English mathematician and professor. In 1822, he persuaded the British government to finance his design to build a machine that would calculate table for logarithms called difference engine. Okay, he has invented two different machines, analytical engine and difference engine. Device was to calculate numbers to 20th place and print them at 4 digits per minute. With Charles Babbage's creation of analytical engine in 1833, computers took the form of general purpose machine. Okay, so this is very great machine, and you can see and you can enjoy also. This video is taken from History Museum, Mountain View, California. Okay, so let us see. So this was mechanical computer, but the beauty of this device is it is able to calculate numbers to 20th place. Okay, so this was the device, uh, analytical engine, used to perform variety of calculations by following a set of instruction or perform stored or punch card. Machine only designed but never built. Okay, so this is the and this device is in working condition. And after his invention, he is considered as father of computer.
एक्सक्यूज मी
Joseph,
सर.
yes.
सर आई थिंक लेबनीज का सर जो मतलब मशीन थी उनकी कैलकुलेटिंग वाली, सर उन्होंने मतलब ये चार्ल्स ने उनका मतलब कॉन्सेप्ट लिया था आई थिंक, और उसे अपग्रेड किया था. मेरे हिसाब से तो ये है सर, उनकी मशीन बिल्कुल वैसी है लेकिन अपग्रेडेड है.
हाँ, बिल्कुल बिल्कुल एकदम सही बात है, लेकिन जो कॉम्प्लिकेशन है, आपने मशीन को देखा है अभी?
हाँ सर.
हाँ, तो the complication of machine is very high. You can see that how complex this machine is. So that's why he is considered as father of computer. Okay?
ओके सर.
Yes. Now come to Jacquard. अब यहाँ तक तो सारी चीजें हो गई थी, हाउ टू कैलकुलेट द थिंग्स, बट हाउ टू एंटर द डेटा. data entry and data retrieval is the problem. Okay, so Joseph Jacquard has built one instrument, and it is known as punch card builder. Okay, so his invention is like a OMR sheet. He has invented a punch card for textile machine. तो जो looms है उसमें automatically punch card में इन्होंने instruction दिया, and this instruction automatically creates cloths. Okay, so let us see how this punch card is used. So this is punch card. Okay, here patterns are given, and on the basis of these patterns, and this loom is still in use.
This is a mechanical Jacquard loom. This technology was developed in France in 1803 by a weaver named Joseph Marie Jacquard. The key thing about this loom is that it controls every warp thread, the threads that go from the front to the back of the loom, individually. Because it can do that, the loom can create very complex, fancy patterns in the cloth more quickly and with greater accuracy than the technology available before this loom was developed. These cards are what carry the instructions that are read by the apparatus on the second floor that tells the loom what pattern to create. The holes in the cards are read by a series of pins up in the apparatus, and those holes tell the apparatus which threads down here should be raised for each pass of my shuttle across the warp. Some of you might recognize these cards as looking similar to computer punch cards. Back in the early days of computer technology, punch cards carried instructions that told the early computers what kind of calculations to do. So this loom is the great-great-great-grandfather of the computer technology that we all use today, and that technology started with a machine that produces cloth.
So this was the pictorial representation how punch card will be created and how it is used in conjunction with looms. Okay.
Excuse me, sir.
Yes.
Sir, like the previous one, the punch card technology which you showed to us, that's more likely related to textile industry.
No.
The looms,
Yes.
patterns, and
Yes. How the patterns are coming.
so by the punch card and all that technology which is given.
Yes. Actually, to automate the things, we need to use punch card. Okay, because each and every time we need to create a pattern, we need to give the instruction to machine. So to give automated instruction, we have make punch in different places. So I will show how the punch cards are working. Okay, this is punch card for looms. Okay, that's why you are getting confused. But yes, from these loom technology, we have devised punch card for computers also, and IBM has developed one computer based on this. Okay, based on punch card machine. So I will show you this. And in the lab of Charles Babbage, she is Ada Baron. Okay, her name is very long. Ada Baron, Countess of Lovelace, and as her name is Countess of Lovelace, and she was first computer programmer. Okay, father of computer is Charles Babbage, and inside Charles Babbage lab, she was there. And let us see some details about
History Who's Who. Welcome to History Who's Who. Who is Ada Lovelace? Ada Lovelace was an English mathematician and scientist and was born on the 10th of November 1815. Her full name is actually Augusta Ada King Noel, Countess of Lovelace. She is now thought to be one of the pioneers of early computers. As a young girl, she was fascinated with maths and science, and at 17 years old, she met a man called Charles Babbage, who had designed a cogwheel calculating machine. Ada was amazed by the model that he had made, and they soon became good friends. In 1834, Charles Babbage began work on another, more elaborate computer called the Analytical Engine, and it had been thought that Ada only had a small part to play in the design. However, modern research has now suggested that Ada played a huge part in designing and writing the programs for the machine. But neither Ada or Charles Babbage ever saw it working in their lifetime. Ada died aged 36 on November the 27th, 1852. The full-size working machine from the designs of Ada and Charles were not made until 2002 by a team of scientists at the London Science Museum. Ada is now regarded as the first ever computer programmer. And that's Ada Lovelace.
Now come to tabulating machine. Okay. So what is the history behind this tabulating machine? And here we use punch card actually. So in case of US census, it was done every 10 years. Process done by hand in 19th century. It took 10 years to complete until. Okay. So Holrich's punch card used electricity rather than mechanical gears. Holes representing information to be tabulated were punched in card. The location of each hole represented a specific piece of information like male versus female. Cards inserted into the machine and metal pins used to open the closed electrical circuit. If the circuit was closed, a computation was increased by 1. Okay, and the population count now took only 6 weeks to count 63 million, and before that it was 10 years. Okay, so this was a device, analog device, but it is based on card. Okay, so Herman Holrich has designed that punch card, and the similar technology actually it is inspired from the loom technology. That's why the introducer says that this machine is great grandfather of computer. Okay, now come to this. So this is very interesting piece of information, and I hope you will enjoy this to see this information. Okay.
The following video is produced by the Computer History Archives Project, dedicated to the study and sharing of vintage computing technologies.
And this is part of operating system
also. In this
also.
video, we take a high-level view of the world of computer punch cards. Most people today are not familiar with computer punch cards used in very large computer systems, except perhaps as seen in very old movies, such as The Billion-Dollar Brain in 1967. Most punch card computers have long since been replaced, but a few still exist and operate. Some are in museum collections. A fascinating element in the history of computing is the role played by punch cards and the wide variety of uses they provided by the early 1960s. Historically, punched cards as a method of controlling the actions of early textile machines goes back to the 18th century. There were a number of early pioneers in this field. For the purposes of this video, we will mention 4 of the most notable. Joseph Marie Jacquard, Charles Babbage, Herman Hollerith, and James L. Powers. Joseph Marie Jacquard, born in 1752, improved on earlier techniques of using punched cards to program the textile machines that performed mechanical weaving. His 1805 punch card loom machine saved considerable time and labor and was widely successful. Charles Babbage, born in 1791, developed the design for an analytical engine, a general-purpose programmable computing engine that borrowed Jacquard's idea for punch cards that provided programmed instructions. Herman Hollerith, born in 1860, developed a mechanical tabulator based on punched cards to rapidly tabulate statistics from millions of pieces of data. His machines were used to record the data from the 1890 U.S. Census. In 1896, he founded the Tabulating Machine Company that later merged with several other companies to become the Computing, Tabulating, and Recording Company, or CTR. In 1924, CTR was renamed International Business Machines Corporation, known by its world-famous initials, IBM. James L. Powers, born in 1871, developed a tabulating machine that differed from Herman Hollerith's and was faster and more economical at the time. In 1911, Powers formed the Powers Tabulating Machine Company. He later changed the name to the Powers Accounting Machine Company for better marketing results. In 1927, Powers Accounting Machine Company merged with the Remington Typewriter Company and Rand Cardex to form Remington Rand. In 1950, Remington Rand acquired the Eckert-Mauchly Computer Company, designers of the UNIVAC. Remington merged with Sperry in 1955 to form Sperry, Rand, and later in 1986 with Burroughs to form Unisys. Today, both IBM and Unisys are global players in information technology solutions, but share the field with many other newer and even larger players. The success of punch card technology, as used by the U.S. government Census Bureau, led to increased use in business applications. During the early 1900s, Remington Rand was a leader in punch card accounting for commercial applications, with IBM a close second. By 1929, however, IBM surpassed Remington Rand as the leading company in supplying machines for business and government, and was better able to survive the economic depression of 1929 and the early 1930s. IBM had switched to using 80-column cards with rectangular holes in 1928. IBM had used round holes in its cards up until that time. The now famous IBM card measured just 7 3/8 by 3 1/4 inches, and that size remained standard for years to come. Remington continued using round holes for many years, but switched to a 90-column format in 1930. By 1940, IBM dominated about 90% of the tabulating market. It became the major supplier to the government of its accounting and later its computing technology for Social Security applications and military applications. Seen here in this 1946 U.S. government video, the ENIAC, the first large-scale digital electronic computer built, used IBM card readers and card punch machines. Punch cards were used both for program instructions for machines and for data input and output. The IBM punch card became the standard medium for data storage up through the 1960s. The widespread acceptance of punch card equipment helped IBM grow a large customer base, giving it an advantage as it moved into the electronic computers age. In 1931, IBM released its Model 600 multiplying punch, IBM's first punch card machine that could multiply. The first calculating punch machines were electromechanical. Later models employed vacuum tube logic. Instructions were hardwired. Later, removable control circuits provided flexibility in programming, such as in the highly successful IBM 604 electronic calculating punch, introduced in 1948. In 1953, IBM announced the 650 magnetic drum data processing machine, one of its early computers. In 1956, it was enhanced as the IBM 650 RAMAX system, with the addition of disk storage units. Nearly 2,000 systems were produced up until 1962. The Model 029 key punch was introduced in 1964 with the IBM System 360 mainframe system. The Model 029 was the workhorse machine for many years. Introduced with System 370 in 1971, the IBM 129 key punch machine was capable of punching, verifying, and being used as an auxiliary online card reader or card punch for attached computers. Here are some examples of punch cards and their various applications. Punched cards were still commonly used for data entry and programming until the mid-1980s. However, the advancement of video display terminals, interactive computing, networks, and personal computers allowed users to efficiently enter data directly into computers from the keyboard or rely on other electronic input with much higher speed and reliability. For more information, please see the following resources.
So this was history of punch card. कोई क्वेश्चन आप पूछना चाहते हो तो पूछ सकते हैं.
सर डेट्स जो है इन सब में जो डेट्स है वो एग्जाम में याद रखने चाहिए.
हाँ, यस.
सर जो डेट्स है अपन ने अभी तक जो भी डेट्स पढ़ी कि कब क्या हुआ तो वो सब याद रखनी है एग्जाम के लिए.
नहीं. It is not necessary to remember all these dates. थोड़ा आपको हल्का पोर्शन जो आगे पीछे का है डेट्स याद नहीं रखना है. ओके. पर आपको ये तो समझ में आ रहा है कि 16th सेंचुरी में क्या हुआ था, 17th में क्या हुआ था, 18th. तो दैट इज वेरी इंपॉर्टेंट. ओके. तो अभी आपने ये मतलब ऐसा तो नहीं लग रहा है कि बहुत ज्यादा ओवरडोज हो रही है वीडियो की?
नो सर.
It's perfect.
Everything is fine.
Okay. So because one more video is there, that's why I'm asking. Okay.
एक्सक्यूज मी सर.
Yes.
सर ये जो सारी मशीन्स जो अभी अपन ने देखी थी पंच कार्ड्स की, ये अभी भी वर्किंग में है या फिर सिर्फ म्यूजियम में रखी हुई है?
नहीं, वर्किंग मशीन्स भी है और म्यूजियम में रखी हुई भी है, और कभी कभी इन मशीन को चार्ज किया जाता है. तो वो इवेंट भी हम देखेंगे. एक्चुअल में अभी आपने पंच कार्ड देखा है कि कहाँ कहाँ यूज कर रहे हैं, पर एक्चुअल पंच कार्ड जैसे कि किसी का नाम एंटर करना है, उसका आईबीएम की जो O29 मशीन जो अभी बता रहा था, उस मशीन को यहाँ पर ये शो कर रहे हैं, है ना. दिस इज द मशीन, डेडिकेटेड मशीन. फाइन. अब हाउ द प्रोग्रामिंग इज गोइंग ऑन. प्रोग्राम कार्ड अलग होते हैं और फिर डेटा कार्ड अलग होते हैं. तो जो भी डेटा फीड करना है उसके लिए हमने अलग कार्ड रखा हुआ है. ये जो अपर पोर्शन दिखाई दे रहा है, यहाँ पर कार्ड्स रखे हुए इस जगह पे. ठीक है. इसके अलावा इस जगह पे हम प्रोग्राम और डेटा कार्ड डालते हैं. तो प्रोग्राम कार्ड मीन्स ऑलरेडी प्रोग्राम इज रिटन इन पंच कार्ड एंड दिस इज द प्रोग्राम कार्ड. ओके. So this we need to feed over here. Fine. And automatically based on its instruction, it will take the data and input. So let us see this video so that you may be able to understand how. And this computer was very popular computer. Okay. So let me start.
All right, we start hard to believe, but one was the O29, and we're going to do punching after its first release. So program 1, auto feed on, print on, punch, we're all good to go. Feed, there you go. Register, off we go. There we go. The 29 Alright, so let's cancel the auto feed, the whole thing, and see what we got here. Hello, so it prints beautifully, it makes nice holes, and let's get the ante up here. So I made my first and best ever program. Actually, it's a set of two programs here to do program-driven entry, which helps you go much faster at punching. And what this one is going to do, it's going to help us fill a first name, last name, born on kind of card. And I won't have to print that, it'll stop and ask me for those fields and format everything. So the first one over here, program mode, program 1, let's do auto feed, and off we go. So now we should be under program control. Feed. Alright, it copied the first field, asked me for the first name. Very good. Next field, mark. Date of birth, I'll put the date of birth of the punch. So, 1, 22, 64, I think I've formatted it, and let's try another one. First name, Thomas. Last name, Watson. And I should have looked that up, but I have no idea when he's born, so let's try 1, 1930. Okay? And so it's much faster to punch card under program control. So that's what you do in production to do repetitive work. So here, it printed first name, and it got here's mark, and look, it nicely formatted the date. Same thing on the Thomas Watson card. So that's working fine. The next feature that would be auto duplicate. So that's another program that would be program 2. Let's take this one, put it over here, and I will duplicate under program control, which is much faster than manual duplicate if I do it right. Program 2, 2, and voila! It should have duplicated that card. Yep, you can do the whole test, right? It's the same one exactly. And then, so that was the second program on the drum. Then last feature, interpreting. I had prepared a beautiful card. that's a mystery card with no marking on the top. And we need to find out what it is, so we put it in here. We go to interpret. Print is on, program doesn't matter, the ODP doesn't matter. So let's see. And here we go, so that's it, found out what was on the card and printed it over here, and of course this is all the letters of the alphabet, the whole set. So give a hand for the IBM 29 key punch for your store.
एक्सक्यूज मी सर
Yes.
सर मतलब इसके मतलब पंच कार्ड यूज कर देते हैं, अगर गलत की दब जाती होगी तो कितने पंच कार्ड खराब हो जा गए होंगे सर उस टाइम में आपके हिसाब से?
नहीं एक्चुअली ये तो इसको मेजर करना तो मुश्किल है, पर ये जो हम प्रोग्राम लिखते थे ये ऐसे नहीं लिखते थे, इनके नंबर होते थे। जैसे हमको कोई भी प्रोग्राम लिखना है तो मूव A, B ये असेंबली कोड्स लिखे होते थे और इसके इक्विवेलेंट एक नंबर होगा 860। ओके, सो वी जस्ट नीड टू टाइप 860। प्रीवियस वो देख के ही टाइप कर रही है, इधर राइट हैंड साइड पे वो क्या टाइप कर रही है उसका ध्यान बहुत कम रहता है, सीधे टाइप करते जा रही है और कार्ड को सॉर्ट करते जा रही है। तो दिस इंस्ट्रक्शन सेट इज नोन एज असेंबली कोड। ओके, एंड आपने अभी हाँ
सर इसमें कोई मतलब गलती हो जाती है तो मतलब हटा नहीं सकते ना सर, उसको बैक में नहीं जा सकते ना फिर?
बिल्कुल हटा, कार्ड को हटाना है और कार्ड एक बार पहले डिबग करना पड़ेगा ना, आपको चेक करना पड़ेगा कि आपने कोड सही एंटर किया कि नहीं। यदि सही एंटर नहीं किया तो हजार्ड आ जाएंगे, मशीन पूरी, क्योंकि सारे के सारे उस इंस्ट्रक्शन पे बेस्ड रहते थे।
पूरा प्रोसेस होने के बाद ही पता चलेगा ना सर?
कार्ड बनने
सही
के
है
बाद पता लगेगा, कार्ड बनने के बाद, और प्रोग्राम तो आप रीड कर ही सकते हो ना। जो आपके पास 97 कॉलम के कार्ड है उतना तो वो रीड ही कर सकते हैं कि हमने प्रोग्राम सही लिखा कि नहीं लिखा है।
ओके सर, ओके।
है ना, और दैट टाइम वी हैव नो डिस्प्ले, और विदाउट डिस्प्ले आपने देखा भी होगा पिछले में जो प्रिंट आउट निकले हैं, और अभी भी जो कार्ड में ऊपर साइड जो है प्रिंट आउट्स आप लोगों को दिखाई दे रहे थे। तो अभी किसी ने क्वेश्चन किया था कि ये सारी चीजें वर्किंग कंडीशन में है कि नहीं, तो ये वर्किंग मॉडल है मार्क 1। सो बिफोर गोइंग टू सी द वीडियो, Howard Aiken ने 1973 Aiken thought he could create a modern and functional model of Babbage Analytical Engine, and he succeeded in securing a grant of $1 million for his purpose, automatic sequence calculator. So the Mark 1 is for SWORD from IBM. Okay, in 1944 the Mark 1 was switched on. Aiken's colossal machine span 51 feet in length, यहाँ आप लोगों को दिखाई दे रहा है, और अभी आप यहाँ पर देखेंगे तो आपको पता लगेगा ये म्यूजियम में वर्किंग कंडीशन में था, हार्वर्ड यूनिवर्सिटी के। ओके, and 8 feet in height, 500 meters of wiring were required to connect each component. The Mark 1 did transform Babbage's dream into reality, and it succeeded in putting IBM's name on the forefront of the computer industry. From 1944 on, modern computer would forever be associated with digital intelligence. Okay, so let us see how this computer works. एक्चुअली फायरिंग वीडियो मैंने नहीं इंक्लूड किया है, पर फायरिंग वीडियो अभी 2019 में फायरिंग वीडियो है ना, इस कंप्यूटर को फायर किया था, एंड ऑल द कंपोनेंट्स आर वर्किंग। So this was the computer developed by Icahn and it is still there in Harvard University. और यदि आप कभी हार्वर्ड यूनिवर्सिटी जाते हैं तो वहां पर आप देख सकते हैं हार्वर्ड यूनिवर्सिटी म्यूजियम में. फाइन. So I think this is sufficient for today, or something more you want to know. So let us start question and answer session. If anybody wants to ask something, they can ask. No question?
Sir, you said
Yes.
you said that Charles Babbage was the father of computer science, but as far as I know, it was Alan Turing.
Alan Turing?
Yes, sir.
No, Alan Turing has invented a Turing machine, and it is a finite automation machine. Charles Babbage is father of computer. Alan Turing has a different credit. Okay.
Okay, sir.
Yes. Yes. So now I request all of you to turn on your camera.
Sir?
Yes.
सर फॉर एग्जाम पर्पस हमको बस मतलब जनरल पता होना चाहिए ना इन सब मशीन्स के बारे में.
हाँ, जनरल पता होना चाहिए, लेकिन अब आप कुछ भी लिख सकते हो आराम से इसको देख के.
सर
कि नहीं लिख सकते हो. यदि मैं आपको थ्योरेटिकल पढ़ाता हूँ एक डायग्राम दिखा के, और यदि आप ये प्रैक्टिकली देख लेते तो आपको तो पूरा विश्वास हो गया कि आपने मशीन देख ली है. नाउ यू आर एबल टू राइट समथिंग अबाउट दिस मशीन. अदरवाइज जस्ट पंच कार्ड होते हैं. कैसे होते हैं? टीचर ने बताया पोस्ट कार्ड जैसे होते हैं. उसको मशीन में हम रख देते थे, ऑटोमेटिकली इट विल रीड द इंफॉर्मेशन. फाइन. सो दिस इज नॉट सफिशिएंट, आई थिंक. Now you have look on a Loom machine also, and modern computer also, and the IBM's computer also. How the punch card is used. और मैंने रियली में पंच कार्ड देखे हुए हैं. यहाँ पर भिलाई स्टील प्लांट है. भिलाई स्टील प्लांट में पहले जो कंप्यूटर्स हुआ करते थे, इट वाज ओपन इन 1964. ओके. तो वहां पर ये पंच कार्ड का यूज करते थे, और पंच कार्ड को जितना वो साइज दिखा रहा उतने ही साइज के IBM कंप्यूटर्स में उसको रखा जाता था. एंड फाइनली इट विल गिव द and it will retrieve the information, and it will automatically print the salary slips and all other things. Okay.